Two concepts likely to be tested on the AP Calc exam that I found were slope fields and Euler's method. Slope fields are graphs used to indicate slope at different points using a differential equation, and they can be used to estimate a line of a graph given a certain point. So for example, we have the differential equation dy dx equals 2xy divided by 3. And it asks us to draw a slope field on the given points indicated. So we have a small graph we have to use. So what you do first is you plug the points into the differential equation. So for example, I've written out 1, 1, so they plug in that into the differential equation dy dx. So d1 equals 2 times 1 times 1, your x and y values, divided by 3, which is 2/3, so your slope is 2/3. So then you go to the point 1, 1 on the graph, and then you just draw a short line with a slope 2/3. So then you repeat this for every point on the graph, and then you have your slope fields finished. So then I added a part, draw the graph using the given value 0, 1. So when you're given a value to draw a graph of using a slope field, you have to kind of just estimate where it would go based on the different slopes. So first you locate your value that you're given. You put a point there, so you know it goes through there. And then you just kind of look at the graph and see what makes sense. So it would make the most sense to go up to these points because they have a really a decently high slope. So then the next concept is the Euler's method. This method uses a table with a differential equation, slope-intercept form, and different points to estimate another point. So to use this method, you have to be given a step value, or you're given 2 points and you determine the step value, or the step size. So the step size is the difference between points. So your table is going to have multiple points like 0, 1, and 2. And your step size is the difference between like 2 of those. So for example, on this one, the step size is 1, which it tells you in the equation. But if it didn't tell you the step size, to determine it, you just use the given point. Like you find the difference of the given point and the final point, divide that by the number of steps that it wants you to use, and you get your step size. So for this one, the final point is f of 2, the given point, the initial condition, is f of 0, so 2 minus 0 is 2 divided by the amount of steps it wants us to use, which would say is 2, and that is 1, and you get the step size. So one thing to remember is to make sure you plug in the correct values for the slope-intercept form, and you bring your y down to the next thing correctly. Not only to plug in the correct values for slope-intercept, but also for your actual slope for your differential equation, because plugging in values is really important for this method. And this is just giving you what you use for your slope-intercept. So y is going to be your next y values, not the row that you're doing the slope-intercept form on, but the next y. M is your slope, which you get from your differential equation when you plug in your x and y. X is your step size, not your actual x value. So our example is 1b. So let y equal f of x be a particular solution to the given differential equation, which is dy dx equals 2xy divided by 3 from the previous problem, with the initial condition f of 0 equals 2. Use Euler's method with step size of 1 to approximate f of 2. So the first thing you do is use the information you're given to make the first row and the x value row. So your given x value is 0, then you use your step size of 1, so you go 0 plus 1, 1 plus 1 is 2, and you get your final value of x equals 2. Then you use your initial condition f of 0 equals 2, so you have your y value, you plug that in. You have your slope because you use your differential equation, plug it in like it shows here, and your slope ends up being 0. And then once you have all three of these, you can plug it into the tangent using your slope-intercept form, y equals mx plus b. So you plug in y equals 0 because your slope 0, 1 because your step size is 1, and plus 2 because your y value is 2. That's your b. Your b is your y value. And then you bring down your 2, your y equals 2, to the next row, and you repeat this, all of what we just did. So you get a slope of 4/3, plug that in, you get your y of 3 1/3, you drag that down, and you have your answer, because this is f of 2, and that's your y, which is 3 1/3. So that's how you use Euler's method in slope fields. That's it.